This slide here we discussed in the overview. It summarizes in a rather complicated fashion what a computing testbed as a service is. If we focus on the left, we have the stack: network as a service, infrastructure as a service, platform as a service, and software as a service. Then if we go into that in more detail, network as a service allows us to use OpenFlow, Genie technologies, and define software-defined networks, allowing us to build virtual clusters in a very flexible fashion. Infrastructure as a service underlies all the virtual machine and cloud approaches. It effectively does software-defined computing. You have hypervisors. We also include bare metal, namely ordinary Linux or Windows clusters, as part of IaaS, and it basically gives you a system with an operating system and possibly a hypervisor. On top of that, you build the middleware, commonly called the platform, and platform as a service. That was originally introduced, that term, for clouds, where you have MapReduce and HDFS and Cassandra and MongoDB and things like that. But also you can have platform as a service for high performance computing, and I illustrate that with Petsy and Saga as HPC and grid technologies respectively. Finally, you can have computer science platforms, such as the sophisticated tools needed to build a compiler, support a bunch of sensors, and things like that. Finally, we have the actual user level, software as a service. You have applications, your favorite, I don't know, chemistry simulation code or quantum chromodynamics code, or you could have your network science MapReduce application. The map and the reduce codes effectively become software as a service, and that possibly can even use GPUs. To enable this, we come to the right, and we have these testbed as a service tools. That's what FutureGrid is built around. We have tools to allow one to provision, to actually put an image on a node. We have software to actually manage the images. That's to have a library of images, and to store images in the library, and to label the images in the library and things like that. We need to go back and forth between different infrastructures as service offerings, HPC and cloud, and within the cloud, the different VM managers. We have tools to do software-defined systems which run at the NAAS and the IaaS levels. At a higher level, we want to have experiment management that controls the whole user experience, allows the user to easily reproduce experiments. And that's an area where more work needs to be done, because the whole concept of reproducible research is still an active research area. The IaaS and NAS needs to be done dynamically. Those are more recent developments. And finally, we need the sort of system engineering, software engineering, DevOps issues like the well-known software, Chef and Puppet. Then if we come to this green box here, that describes typical dynamic tools we developed. FutureGrid Rain, it has a subset of tools called Cloud Mesh, but it basically supports this dynamic provisioning of images. It has the image management in it, and it does provisioning on demand, and the Rain will involve creating, deploying, and provisioning images, which is the capabilities we put up here in this flesh-colored entity here. This slide gives you some selected list of important services FutureGrid has. Going from the left, we start off with the cloud platform as a service services, Hadoop iterative MapReduce, which is Twister at Indiana University, the Hadoop file system, HBase, which is built on HDFS, which is the original open source version of Google's big table technology, and Swift, which is the object store from OpenStack. At the infrastructure as a service level, we have Nimbus, Eucalyptus, OpenStack. Those are the three we support. And then we have also need to also virtualize a network in some cases. That's what's supported by Vine. Here we have Grid as a service, Genesis, 2, Unicore, Saga, Globus. High performance computing as a service, MPI, OpenMP, CUDA. I don't think we have any users of Petsy, but if we did, Petsy would be added to this offering. Finally, we have the same tools we discussed on the previous slide to actually build a testbed as a service. And these are the services, and then we have Rain and Cloud Mesh. In addition to that, we have the portal, we have the monitoring systems, Inca and Ganglia, we have the DevOps, Chef, Puppet, Salt, and we have the experiment management software such as Pegasus.